let's assume that the battery has died in your airplane and you're going to have to hand prop the engine in order to get the aircraft started. If you do have to hand prop the aircraft, it is very important that the person at the controls be a competent pilot when you're hand propping. Do not use a passenger who is not a pilot at the controls when you're hand propping the aircraft engine. There have been some very unpleasant accidents where the plane started, the passenger didn't know how to keep it under control, and the plane ran away with them and either ran into a hangar or, in some cases, it's actually gotten airborne with a non-pilot passenger at the controls, which is not very pleasant. So make sure you've got a competent pilot at the controls if you're hand propping the aircraft engine. Now, after you start the aircraft engine, the first thing you want to do is adjust the RPM to the proper reading and then check for the desired indications on the engine gauges. Especially what you're checking for is oil pressure. You don't want to run an engine without oil pressure, so make sure that oil pressure comes up into the green. Aircraft engines have dual ignition systems on them for a couple of reasons. One of the reasons is safety. Two ignition systems, so in case one of them fails, you've got another. But the second purpose of the dual ignition system is to provide for improved engine performance by having two separate magnetos and two spark plugs in each cylinder. You've got smoother ignition of fuel and you've got improved engine performance. Now, many aircraft have an auxiliary electric fuel pump installed, and that electric fuel pump is used as a backup in case the engine-driven fuel pump fails. It's often used as an aid in starting the aircraft, and on many aircraft you turn the auxiliary pump on for takeoff and also on for the landing, but it is not designed to be operated constantly because it would wear out pretty quickly that way and not be available when you needed it. Its primary purpose is to be there as a backup if the engine-driven pump fails. Now, what would happen if you have electrical problems in flight? Well, not as much as you might think. For example, suppose you lose your complete electrical system. That means you have both a dead battery and a dead alternator. You're going to have a lot of gauges going to zero, and that sure gets your attention. But will your engine fail? No. Your engine-driven fuel pump and your independent magneto ignition system will keep your engine running. But you will lose your installed avionics equipment, such as communication and navigation radios and your transponder. So you'll have to plan to land without the convenience of your radios. You'll also be landing without lights, and if you have electrical flaps, without flaps. So you might consider landing at a nearby airport that does not have a control tower, one that has good runway choices and lower traffic levels. But you should be able to count on your engine to take you there. Let's assume that you do a takeoff, and after you're airborne, guess what happens? Oh no, you have a power failure. The engine on the aircraft quits. So, what is the most important thing to do first? Well, the most important thing to do is immediately establish the proper gliding attitude and airspeed. Keep the aircraft under control and get it to the best airspeed. It doesn't matter where the wind is from. It doesn't matter where you're going to put the airplane if you stall and come down out of the sky like a leaf. The most important thing to do is get the proper gliding attitude and airspeed. After that, you can worry about the wind and where you're going to land the airplane and things like that. So, suppose you do have to land downwind because you had a power failure, an engine failure like that. What should you expect on that landing? Well, on a downwind landing, you should expect that you'll have a faster ground speed on touchdown because the wind is behind you instead of in front of you. That faster ground speed will give you a longer ground roll. And on the approach,
you're going to have a likelihood of overshooting your desired touchdown point. And let's talk about why that would happen. Here is your normal approach, let's say, coming in to land at this spot on the runway or on a field for your emergency landing. When you have a wind behind you, it's a downwind landing, that's going to tend to blow you beyond your normal touchdown point if you keep the same pitch angle, the same descent angle as you would on a normal approach. And this will give you a higher likelihood of overshooting your desired touchdown point.